Exactly. Better, yeah. And with you on the docket.
Glad you're happy.
No, we can observe change.
We have enough time.
And which one doesn't?
No checking email.
Okay.
How am I going to get?
I have.
Yeah, by the time I got in here last.
This hearing will come to order. Good morning. We have with us today 6 distinguished scientists who authored chapters of the second part of the Intergovernmental Panel on Climate Change report that was released in Brussels on April the 6th. We know you have been on a whirlwind tour, and we appreciate you coming and joining us today. This second report moves beyond the fact that global warming is occurring to provide us with a picture of what global warming means for natural systems and human communities throughout the world. For the near term, the picture is a mosaic of positive and negative impacts. Some areas are now experiencing changes that have put them at greater risk from drought, avalanches, floods, and fires. For others, there are benefits from the form of lower heating costs, fewer deaths due to cold exposure, lengthening growing seasons, and increases in crop yield. Even our natural security would be impacted by the effect of climate change. Recently, the Pentagon released a study entitled The National Security and a Threat of Climate Change, which looks at possible security problems including mass migrations, increased border tensions, greater demands for rescue and evacuation efforts, and conflicts over essential resources including food and water. In the long term, negative impacts begin to overtake the positive impacts. If we do not reduce emissions of greenhouse gases, our children and our grandchildren will face considerable challenges due to climate change in the latter half of this century. In the near term, it appears we can implement strategies to cope with climate change impacts. We must start to adapt because the climate is changing and will continue to change even if we reduce emissions tomorrow. Adaptation will help our generation to cope with climate change. However, only mitigation will avoid and delay severe climate change impacts our children and grandchildren are projected to face. I do not want to leave my daughter, her generation, with the burden of a world with more food shortages, extended droughts, displaced coastal communities, increased public health problems, and political instability created by increased numbers of people displaced by climate-driven changes in their environment. The information brought to us in this report makes a compelling case for action. We need to make our communities more climate resistant. Adaptation is an essential near-term step to reduce vulnerability to climate change. But adaptation alone is not enough. We owe it to our children and our future generations to lead the world in a global effort to reduce greenhouse gas emissions. I thank our witnesses for appearing before us today, and I also thank you for your service to the IPCC. I look forward to hearing your testimony, and at this time I am pleased to yield to Distinguished Ranking Member Mr. Hall for an opening statement.
Mr. Chairman, good morning. Glad that our good chairman organized this hearing about the important topic of climate change impacts, adaptation and vulnerability. And let me start by thanking all of the witnesses for being here today. Climate change is becoming a very key issue in the 110th Congress, and we all appreciate your time and the scientific expertise that you can provide for our consideration. Climate change is one of our nation's biggest challenges, but so too are the equally important challenges of energy independence and affordability. Our nation needs solutions that address all of these issues, and they need to be mutually exclusive goals. We can and should develop affordable energy solutions that reduce our carbon intensity while freeing our nation from the grip of foreign energy. The scientific findings of this second IPCC working group will prompt much debate about what policies the United States should enact to address the potential impacts of climate change. The findings in the Working Group 2's report have even more uncertainty than those in the Working Group 1 report we heard about back in February. Some in Congress are proposing bills that would create a mandatory regulatory scheme to address carbon emissions. And considering these pieces of legislation, we must also and always weigh the cost and the benefits of the unintended, along with the unintended consequences that could result. The scientists at our hearing today can tell us their best analysis of what climate effects to expect at certain temperatures, but they can't answer the policy issues posed above. One issue that most of us agree on is that our country will experience impacts from climate change, and we need to be ready to adapt to them. I have faith in American innovation in finding solutions to help us adapt to these changes. Last year, I authored the National Integrated Drought Information System Act that authorized a program to improve drought forecasting and allow localities to better manage their water resources. Adaptation will be important, and I look forward to hearing from these experts as they explain their findings in this key area. In the long run, the key to addressing climate change will be clean, affordable, and reliable energy technologies. We need much more discussion in Congress on how new technologies can help America become energy independent and create a world with cleaner energy sources. There's a concentrated effort by a minority of the environmental community to declare war on energy and to declare war on growth in general and a war on fossil fuels specifically. They need to realize that if China offers $1 a barrel of oil more than the U.S. now pays Saudi Arabia, we could overnight lose 60% of the energy we have from, guess what, fossil fuels. Let us not be ridiculous about our energy needs simply to give some politician or some editor a plaque for their walls. I yield back my time.
Thank you, Mr. Hall, and I think there are lots of areas within your statement that we have a consensus on and look forward to working with you. If there are members who wish to submit additional opening statements, your statements will be added to the record. At this time, I would like to introduce our witnesses. First, Dr. Cynthia Rosenzweig was the coordinating lead author for Chapter 1, Assessment and Observed Changes and Response in the Natural and Managed Systems of the Working Group Number 2, Report on Impacts, Adaptation, and Vulnerability. Currently, Dr. Rosenzweig is a senior research scientist at NASA Goddard Institute for Space Studies, where she heads up the Climate Impacts Group. Welcome. Our next witness will be Dr. William Easterling, served as coordinating lead author for Chapter 5, Food, Fiber, and Forest Products. Dr. Easterling is the director of Pennsylvania State University Institutes of the Environment, and as of July the 1st, will become Dean of the College of Earth and Mineral Sciences at Penn State. And Dr. Roger Pulwarty was the lead author of Chapter 17, Assessment of Adaptation Practices, Opinions, and Constraints and Capacity. Currently, Dr. Pulwarty is the physical scientist at the NOAA Cyrus Climate Diagnostics Center in Boulder, Colorado. And Dr. Stephen Snyder is professor of interdisciplinary environmental studies, biological sciences, and civil environmental engineering, and co-director of the Center for Environmental Science and Policy and Interdisciplinary Program in Environment and Resources at Stanford University. Dr. Snyder served as the coordinating lead author for Chapter 19, Assessing Key Vulnerabilities and the Risk of Climate Change. And I know Mr. Molassant would like to be here. I think he's on his way because he has a constituent in Dr. Virginia Burkett, who is the lead author of Chapter 6, Coastal Systems in Low-Lying Areas, and USGS Global Change Science Coordinator at the National Wetlands Research Center. So when Mr. Molassant comes here, we'll even say nice things about you, Dr. Burkett. We do thank you for coming. You've been on a whirlwind. I know this has been a very tough few years getting ready for this. I know some of our previous authors in the Chapter 1 said it was the most really physically, intellectually demanding thing they have been through. And so we appreciate your work and we welcome you here. And let's see, Mr. Hall had to make testimony at another hearing, and we're glad that Dr. Ehlers is here for introduction of the final witness. Okay, he's not. Well, let's see. We have does the minority have a witness here? Yes. Let me just, and I'm going to let you help me. This is, you want to go forward? Okay. Here's.
Sorry about the confusion, but Mr. Hall had to leave for an urgent meeting. I'm very pleased to introduce Mr. Shardul Agrawala. Thank you very much for participating here in this particular event. And I might add that I admire all of you for your willingness to depart the comfort of your individual offices scattered around the country and to participate in this exhausting and exhaustive work that you have done. And I deeply appreciate it. With that, I'll return it to the chair.
Thank you, Dr. Ehlers. The previous chairman, Sherry Bowler, who is blocked out from us right now with the screen, used to say that although witnesses are supposed to complete their testimony in 5 minutes, that 300 seconds on a very important issue like we have today is a little bit confining. So we do have your regular testimony, so we hope you'll summarize, but we don't want you to feel under great constraints when the red button comes. But we would like to get home tonight. So Dr. Rosenzweig, we'll yield to you.
Thank you, Mr. Chairman. My testimony comes from Section B of the Working Group 2 Contribution to the Intergovernmental Panel on Climate Change, which is called Climate Change 2007, Climate Change Impacts, Adaptation, and Vulnerability. This is from the approved summary for policymakers. This part of the summary concerns the relationship between observed climate changes and recent observed changes in natural and human environments. The statements presented here are based largely on data sets that cover the period since 1970. The number of studies of observed trends in the physical and biological environment and their relationship to regional climate changes has increased greatly since the third assessment in 2001. The map shows the temperature rises since 1970 and the data series of changes in physical and biological systems that were assessed in the chapter. From the current assessment, we conclude that observational evidence from all continents and most oceans shows that many natural systems are being affected by regional climate changes, particularly temperature increases. With regard to changes in snow, ice, and frozen ground, including permafrost, examples are enlargement and increased numbers of glacial lakes, increasing ground instability in permafrost regions, and rock avalanches in mountain regions. There are also changes in some Arctic and Antarctic ecosystems, including those in sea ice biomes and also predators high in the food chain, among them polar bears. The following types of hydrological systems are being affected around the world: increased runoff and earlier spring peak discharge in many glacier and snow-fed rivers, and warming of lakes and rivers in many regions with effects on thermal structure and water quality. Recent warming is also strongly affecting terrestrial biological systems, such as earlier timing of spring events. Examples are leaf unfolding and blooming, bird migration and egg laying, and poleward and upward shifts in ranges in plant and animal species. There is also substantial new evidence about observed changes in marine and freshwater biological systems. These include shifts in ranges and changes in algal, plankton, and fish abundance in high-latitude oceans, increases in algal and zooplankton abundance in high-latitude and high-altitude lakes, range changes and earlier migrations of fish in rivers. The changes I just described were responding at the regional scale. What in Chapter 1 we also did was do a global assessment looking at all of the changes, assessing all the changes together. Here we find that a global assessment of data since 1970 has shown it is likely that anthropogenic warming has had a discernible influence on many physical and biological systems. There are 4 sets of evidence which, taken together, support this conclusion. The first is coming from our colleagues in Working Group 1, who concluded that most of the observed increase in the globally average temperature since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. The second line of evidence is of the more than 29,000 observational data series. There are dots representing 29,000 data series from 75 studies that show significant change in many physical and biological systems. More than 89% are consistent with the direction of change exhibited as a response of warming. The third line of evidence is that a global synthesis of studies in this assessment strongly demonstrates that the spatial agreement between the regions of warming, of significant warming across the globe, and the locations of the significant observed changes in the natural systems consistent with warming is very unlikely to be due solely to natural variability of the temperatures, nor of the systems themselves. Finally, there have been several modeling studies that have linked responses in some physical and biological systems to anthropogenic warming. Consistency between the observed and modeled changes in several studies and the spatial agreement between significant regional warming and consistent impacts at the global scale is sufficient to conclude with high confidence that anthropogenic warming over the last 3 decades has had a discernible influence on many physical and biological systems. Thank you, Mr. Chairman.
Thank you, Dr. Ziegenweg. And now, Dr. William Easterling is recognized for 5 minutes.
Good morning, Chairman Gordon and distinguished members of the committee, and ladies and gentlemen. I'm Bill Easterling, and since I was introduced, I will dispense with a lot of background information and just get straight to the point. I think that one of the great human achievements of the 20th century was the progress that the world's farmers made in increasing global food production, a step with the increase in demand for food. Even though hunger certainly persists everywhere in the world, there is no question that the farmers have been successful in generating the calories that we need to feed the planet. And the question before us, and this was one of the central questions we asked in the IPCC report on food and fiber and forestry, was can this continue in the future under climate change? Let me begin by saying that a large amount of progress has been made since the last IPCC report in understanding and projecting the effects of future climate change on agricultural production, although, to be sure, significant uncertainties remain. It can now be stated with higher confidence than before that climate change is likely to challenge food security among the world's poorest people, particularly in countries in the low latitudes in the tropics. Most of the crops are grown there under conditions that are near the top of those crops' optimal temperature range, and any warming at all pushes them over the top and yields begin to fall. Now, my first slide, although it's difficult to see, I know, from where you are, but it is a snapshot, and I'll walk you through it, tells this story with a series of graphs that show the synthesis of nearly 70 recent modeling studies that have been divided between the temperate mid to high latitudes and the tropical low latitudes. And on these graphs, the cereal crops maize, or as we know it, corn, wheat, and rice yields, which those, by the way, 3 cereals make up about 75 to 80% of the total calories either consumed by us as humans or by livestock as feed, are shown as percentages of current yields versus increasing mean temperature. We thought this to be an effective way of summarizing what we've learned about the effects of warming on crop yields. Many of these studies were performed with, quote unquote, and without adaptation assumptions. and the adaptations might be changes in planting times and cultivar selections, commonsensical adaptations that farmers would probably engage on their own. The red dots and lines are results without adaptation, and the green dots and lines are with adaptation. So notice that the red lines for the tropics show yields in all three crops dropping below current levels after a little more than 1 degree Celsius of warming. Now, the warming will be less troublesome, according to our analysis, to agricultural systems in the mid to high latitudes, like the U.S., at least in the early stages of the warming. And notice the red lines for the temperate mid to high latitude crops remain above the current yields for the first few degrees of warming before they begin to tail off. The green lines indicate that adaptation effectively keeps the temperate cereal crops near or above current yields through moderate amounts of warming, say about 4 to 5 degrees Celsius of warming, but it only protects low-latitude tropical crops for a few degrees, maybe about 3 degrees of warming. All of the studies in these graphs include the beneficial effect of rising atmospheric CO2 or carbon dioxide levels on crop growth. This is the so-called CO2 fertilization effect. There has been recent controversy over the strength of the CO2 fertilization effect, with some scientists feeling that we've tended to overestimate the strength. This would imply that our global estimates of climate change damages to food production from previous studies are too low. There are arguments, scientists who are questioning the CO2 effect are based on the most recent and realistic field experiments to date. The second slide gives you a visual snapshot of the old and new experimental approaches. And the old approach is the chamber experimental approach that's on the left side. It's a very artificial environment versus the newer free air carbon enrichment rings out in fields where the CO2 is actually applied in measured ways to simulate a much more realistic environment. Our assessment after careful comparison of the older experimental results with the new ones is that the effects are not enough different to warrant concern. Our third slide shows how we reached this conclusion. It shows wheat yields as percentages of current yields versus different levels of atmospheric CO2 for both the old and the new experiments. While there are too many old experiment data points to plot them all, it would make this look like a bowl of spaghetti. These data points are fully contained within the blue shaded range on the graph. The red line describes the general trend of the old experiments, and the 3 data points for the new experiments are plotted as red triangles at 550 parts per million CO2. Looking at it this way shows that the new results are well within the range of the old results, and the green oval on the graph brings it to your attention. Hence, our conclusion is that the existing estimates of CO2 effects on food supply under climate change would appear to be valid. And my final point, and Mr. Chairman, I can summarize this in just a matter of a minute or two, is that a growing preponderance of studies show that if the climate changes are accompanied by increasing climate variability, droughts and floods, and extreme events like those, crop yield losses are likely to occur at even smaller mean temperature increases than if variability is unchanged. So the numbers I showed you before might look a bit different if variability changes appreciably from our current experience. For example, one study computed that under scenarios of increased heavy precipitation, production losses due to excessive soil moisture would double in the U.S. by 2030. Those are among the more important findings of our chapter, and I thank you for your attention and would be happy to answer questions at the appropriate time.
Dr. Burkett, you're recognized for 5 minutes.
My name is Virginia Burkett, and it's a pleasure to be here, Mr. Chairman and Committee. I'm a scientist with the U.S. Geological Survey and one of 8 co-authors of the coastal chapter. My co-authors are listed here from many countries. The key policy relevant findings in the coastal chapter are, number one, that coasts are already experiencing the adverse consequences of climate-related hazards and sea level rise. Number two, coasts will be exposed to increasing risk over the coming decades as sea level rises and the climate changes. Number three, the impact of climate change on coast is exacerbated by increased human development activity, which we found to have a greater impact on coast during the past century than did climate change. Or adaptation of coast for developing countries will be more challenging than for developed nations simply due to constraints on adaptive capacity, whether technological, financial, or institutional. 5, adaptation costs are much less generally than the cost of inaction. And finally, the unavoidability of sea level rise conflicts with present-day human development patterns and trends. We examined potential effects of climate change on all major types of coastal systems, ranging from coastal wetlands to coral reefs to seagrasses to barrier islands and coastal forests. And the top line of this graphic shows the 6 major drivers of change. The first on the left being increase in tropical storm intensity and wave regime, accelerated sea level rise, increased temperature, increased CO2 concentrations, and finally changes in runoff, which are due to changes in precipitation and also due to the increase in temperature, which causes a faster evaporation of surface waters. Each of these climate-related processes plays an important role in structuring coastal systems, but all coastal systems are not equally vulnerable. A wetland in one place is not the same as a wetland in another place in terms of its vulnerability. This slide lists some of the key vulnerabilities of coastal systems in America. Our chapter dealt with all of the world, of course, but these are some things I pulled out from one of our tables. For example, there are over 1,000 U.S. protected islands in the Pacific, many of which have a mean elevation of 3 to 10 feet above sea level. Sea level rise will affect the water supply of many of these islands a long time before the population is flooded. Shifting closer to the mainland at Dauphin Island, Alabama, here's one of our LIDAR images from our St. Pete lab. The little green things with the tops are red. Those are houses. You can see the Gulf of Mexico on the left and the Mississippi Sound, and you can see the road going down the island prior to Hurricane Ivan. The impacts of Hurricane Ivan on this island and Hurricane Katrina provide a good illustration of how the predicted increase in hurricane intensity might affect low-lying coastal barriers of the southeast along the Gulf of Mexico and the Atlantic border. The IPCC report contains a cross-chapter study of megadeltas, which are among the most vulnerable regions to climate change in the world. Human societies in Asian megadeltas are considered most vulnerable because of their high exposure to risk, high population concentration, and lack of adaptive capacity. In North America, the Mississippi River Delta is the best example, and it is ranked as highly vulnerable in our chapter. In the subsiding Mississippi Delta, even minor changes in the rate of sea level rise will have serious impacts on coastal wetlands and barrier islands, which protect the city of New Orleans, for example. Everything in red and yellow on this slide was converted to open water during the past 70 years. And if you look at the landfall of Hurricane Katrina, you can see it in yellow there, and you can see the land loss in the New Orleans area just overnight, in addition to what was shown on the earlier slide. And that's what the Chandelier Island chain looks like now. The left is before the storm, the right is after the storm. And here it looks like the flip side, like you just turned the Louisiana land loss map upside down, and it's land loss in coastal Alaska, where the land is sinking, the permafrost is thawing, it's 70% ice, the substrate is there. the sea ice has retreated, and so the erosion of wave attack along that coast has accelerated, and it looks like it's accelerating. This is just 50 years of land change. There are substantial investments in infrastructure here, like the National Petroleum Reserve in Alaska. This well here was drilled in 1970s. You can see how the land has collapsed under it, and the erosion has affected the shore face. And in addition to the infrastructure there are many native communities that will have to move.
Thank you, Dr. Burkett. And to complete your abbreviated introduction, I'd like to recognize Mr. Melanson.
Thank you, Mr. Chairman. I'd like to say hello to Dr. Burkett. I guess that's a new phenomenon for me to call her Burkett. She was Dr. Virginia Van Sickle when we worked together back in the 70s. I was with the Regional Planning Commission. She was a new young scientist on the block, so to speak, and has proved her mettle. Back then it was called Coastal Zone Management. Now it's called Coastal Erosion Restoration. You can give it a whole lot of different names, but as you saw by just the one slide that showed the areas to the east of Louisiana, and those that are my district, which is the fastest disappearing district, I believe, in the United States, landmass-wise. She has done quite credible work. I'm proud to call her a friend, a former associate, and I'd like to welcome her here, and sorry I was running late to get here. I'm trying to visit with people that are still continuing to flow through my office word about coastal restoration, hurricane recovery, rebuild, and other items that have kept my plate quite full. But it's good seeing you again, Virginia, and welcome.
Dr. Agarwal is recognized for 5 minutes. And you might want to get your microphone.
Okay. Chairman Gordon and members of the committee, thank you for the opportunity to testify this morning. I'm a visiting senior fellow at the Woodrow Wilson School of Public and International Affairs at Princeton University. I'm currently on sabbatical from the Organization for Economic Cooperation and Development in Paris. A short biography can be found at the end of my written testimony. I served as the coordinating lead author for the chapter on assessment of adaptation practices, options, constraints, and capacity in the fourth assessment report of the IPCC. Dr. Pulwarty, sitting next to me, was also on this chapter and would be talking next about some of the implications for the U.S. My testimony will cover some of the broad findings on adaptation coming out of this chapter. I'd like to offer 5 take-home messages. The first point I'd like to make is that climate policy is not about making a choice between adapting to and mitigating climate change. Even the most stringent mitigation efforts cannot avoid further impacts of climate change in the next few decades, which makes adaptation essential. On the other hand, unmitigated climate change would, in the long term, exceed the capacity of natural and human systems to adapt. Second, societies have a long record of adapting to the impacts of weather and climate. In other words, adaptation is not a hypothetical concept. It is taking place now. Crop diversification, drought monitoring, and flood protection are only some of the examples of proactive adaptation measures. Adaptation can also be reactive, for example, emergency response, disaster recovery, and even migration. Our ability to adapt proactively to current climate variability has increased significantly in recent decades, primarily due to the development of operational forecasts of El Nino and La Nina. NOAA and other agencies have been central to this progress. My third point is that climate change will also require responses that go beyond adapting to current climate. Climate change often poses novel risks outside the range of experience. For example, through accelerated glacier retreat and permafrost melt, and changes in the intensity of heat waves and hurricanes. Even when the impacts of climate change are not yet evident, scenarios of future impacts may already be sufficient to justify some adaptation measures, particularly for long-lived infrastructure. Just to give one example, a sewage treatment facility on Deer Island in Boston Harbor was constructed in 1998 at a much higher elevation
taking into account anticipated sea level rise. New York City, meanwhile, is considering scenarios of future changes in temperature, rainfall, sea level rise, and extreme events as part of its review of water supply options. Dr. Rosenzweig on this panel, in fact, is involved in these efforts. My fourth point is that despite our experience and expertise, adaptation is not a slam dunk. There are substantial limits and barriers. Even rich countries have vulnerable populations. Hurricane Katrina is a prominent example, but it is not the only one. There were 15,000 excess deaths in less than a month in France in the 2003 heat wave. Further, demographic trends and social choices have, in many cases, resulted in maladaptation, and Dr. Burkett mentioned some of the cases. Even adaptations that have been put in place to reduce current risks, such as levees, could engender a false sense of complacence and exacerbate longer-term vulnerabilities if they do not incorporate the full range of risk possibilities in their design. Costs are another barrier. A recent estimate by the World Bank puts the global incremental annual costs of adaptation to climate change to be between 10 billion and 40 billion US dollars a year. Information on costs, however, remains very preliminary. We also lack usable information. Many adaptation decisions are very local, at the level of households, farms, watersheds, infrastructure projects, and cities, where reliable climate scenarios are often lacking. Users also often need information on a whole range of climate-related variables: rainfall, dry spells, winds, snow cover, temperature, and rainfall extremes for their decisions, and often such information is either not reliably predicted by climate models or not available. Even when information exists, access to it is not universal. Further, adaptation is also often not a team sport. Actions by one person or a group can often compound the vulnerability of others. My fifth and final point is that there's a significant role for public policy on adaptation. Adaptation needs to be treated as a core component of a comprehensive climate policy. To be effective, consideration of climate risks needs to be integrated within broader programs, ranging from natural resource management to disaster reduction to international development assistance. Adaptation should not be pigeonholed as an issue just for climate policy. In many cases, climate change would require only tweaking of existing policies or better enforcement of existing regulations. Buy-in from regulatory agencies is therefore critical. In certain cases, climate change would require early actions. In particular, some of the impacts mentioned by Dr. Rosenzweig, for example, changes in snow cover, permafrost melt, and so on, are examples of climate change impacts occurring now where adaptation measures are needed. Adaptation to climate change is also needed for infrastructure decisions, where decisions today might have a long-term lock-in. Government can also play a role in incentivizing adaptation by private actors. In particular, market mechanisms are still underutilized for adaptation. Finally, further efforts are also needed in the development and provision of usable knowledge for adaptation. This may require an integrated suite of climate information products, ranging from climate monitoring to seasonal to interannual forecasts, as well as projections for climate change. Thank you.
Thank you. Dr. Pulwarty, you are recognized for 5 minutes.
Good morning, Chairman Gordon, Mr. Ehlers, and the other members of the committee. Thank you for this opportunity to speak to you about Working Group 2 of the IPCC. My name is Roger Pulwarty. I'm a physical scientist in the NOAA Oceanic and Atmospheric Research Climate Program Office and the program manager for the U.S. National Integrated Drought Information System, or NIDIS, that was mentioned by Mr. Hall this morning. I had the honor of serving as the lead author on Chapter 17, as you've heard, also contributing to Chapter 3 on freshwater resources and their management, a lead author on the forthcoming IPCC Special Report on Climate Change and Water, and the U.S. Climate Change Science Program Report on Weather and Climate Extremes in a Changing Climate. I will focus my testimony on the results of Chapter 17, especially as they relate to the United States and to water resources. Chapter 17 sought to address the following questions in the context of climate. What are adaptation strategies, as you heard, and how can they be implemented? What are the benefits, costs, and limits of such adaptation strategies? And more importantly, what are in fact good adaptation practices?
The IPCC definition of climate change refers to any change in climate over time, whether due to natural variability or as a result of human activity. It is thus the goal of good adaptation strategies to take advantage of opportunities and to reduce the risks associated with variability and change. It's important to note that climate change could, in the long term, exceed the capacity of particular natural and managed systems to adapt. Climate change adaptation strategies will be important for various sectors of the U.S. economy and society and may be implemented in a number of ways. Some adaptation strategies and initiatives are infrastructure-based and may require major upfront investments. One example that you've heard about is the Dare Island Sewage Facility in Boston Harbor, which, it should be noted, was completed in 1998. A more complex but potentially major mode of adaptation to climate change will involve shifts in land use, watershed, ecosystems, and livelihoods. Adaptation strategies and practices in the United States have been observed in the insurance sector and are focused on property damage. As a result of climate change, demand for insurance products is expected to increase. At the same time, however, climate change effects could reduce insurability and threaten insurance schemes, possibly resulting in the states becoming the insurer of last resort. As we have seen in the aftermath of recent hurricane seasons, such as 2004 and 2005, it can take only one major climatic event to set such changes into motion. Adaptation strategies and implementation initiatives in infrastructure, insurance, financial markets, and collaborative resource management may be needed to address water availability and quality. One critical area is the western United States. Projected warming in the western mountains of North America is very likely to cause decreased snowpack, more winter flooding due to earlier runoff, and reduced summer flows. These effects will exacerbate competition for already overallocated water resources. For example, in the case of Sacramento-San Joaquin rivers and the Colorado River Basin, stream flow changes projected beyond 2020 indicate that it may not be possible to fulfill water demands in those basins. If climate change results in greater water scarcity relative to demands, future adaptations will be necessary to address competition for water and may include improved water use efficiency and better demand management through metering, pricing, and other mechanisms. We might also have to address institutional changes that improve the tradability of water rights while securing water for the environmental services that we depend upon. Voluntary water transfers, including short-term water leasing, the permanent sale of water rights from agricultural to urban and environmental uses, are becoming increasingly common in our western states. In California, adaptive management measures include water conservation, reclamation, and the combined use of surface and groundwater and the desalination of brackish water. These have all been advocated as means of proactively responding to water scarcity. It takes time to fully implement such changes, so adaptations such as these are likely to become more effective as we learn and time passes. A major barrier to implementing adaptive measures in the United States is that adaptation is not currently a high priority. Many adaptation strategies can be implemented at low cost, but comprehensive estimates of adaptation costs, benefits, and the limitations of the practices themselves are currently lacking. Coping with uncertainties associated with estimates of future climate change and the effects on economic and environmental resources means that we will have to adopt management strategies and measures that are robust enough to apply across a range of potential scenarios about the future. Adaptive capacity to manage climate changes can be increased by introducing adaptation measures into existing watershed, water resources, urban and coastal management plans and operations. One option based on experience is to develop research and management partnerships that provide decision makers with credible, relevant, and timely climate information, and to improve the capacity to use such information for risk management. The IPCC report refers to such activities as mainstreaming. By doing so, adaptation to climate change will become part of other well-established programs to increase societal resilience and to increase national benefit. I'm happy to answer questions that the members might have. Thank you.
Thank you, Doctor. And Dr. Snyder, you're recognized.
Thank you very much, Congressman Gordon. Distinguished members, if you'd indulge me in a short personal preference, for me, sitting here under the watchful eye of George Brown, reminding myself that 31 years ago, as a 31-year-old, I first testified to this committee. And at the time, the issue was creating a National Climate Program Office to deal with the fact that even then we were well aware that the use of the atmosphere as the recipient for tailpipe and smokestack emissions could well cause problems from the climate point of view. We were just becoming aware at the time that warming was emerging from cooling as the most likely event, and clearly it was mostly theoretical projections forward for which we wanted to create the office. If I had to summarize, as I'm often forced to do in a media interview, so what's new in the last 31 years, I would argue that I guess it's that nature has been cooperating with theory, and the projections of discernible change by the end of the century, increased heat waves, reduced cool waves, and the further stress on things such as intensity of hurricanes would occur and did. Ice would be shrinking, as we heard from Cynthia Rosenzweig and so forth. So it isn't that there's a great breakthrough in our theoretical understanding since 31 years ago. It's that some of those concerns have become so manifest in the observational record that there's now a much larger constituency for paying serious attention to the problem, and I appreciate your interests in that. So with that having been said, I have been the coordinating lead author with others of a summary chapter, Chapter 19 in the Working Group 2 report, which is the key vulnerabilities and the risks from climate change. Now, IPCC tends to be a rather arcane venture to many people with snippets in the press, and I thought I would spend a minute of my time just giving you a little background on how we get to choose what we write about and what literature we assess. First, I would say that we aren't simply librarians. It is not our job just to say what's in the literature, and there's so much you can't put it all in anyway in an 800-page report. Our job is to assess what's relevant to the questions given to us by governments, which are policy relevant to them, and to be sure that we provide clear statements of the credibility of the science so that confidence judgments can be made, whether it's likely or speculative and so forth. So I'm just going to show you now, and I guess the last thing you want after a long panel is lots of words. So I've highlighted in red the key words, given our title is Key Vulnerability, of our plenary agreed outline. This is a negotiated document by the over 100 governments that meet and that give us a direction which all chapters are required to do, and I give you the example for my chapter. If you want to see it in detail, it's in my written submission. But just to highlight a few issues, in the front bullet, issues related to Article 2 of the UN Framework Convention on Climate Change. That's the one which said that nations are committed to stabilize greenhouse gas concentrations in the atmosphere so as to prevent, quote, dangerous anthropogenic interference with the climate system. We also were asked to identify key impacts and vulnerabilities, key risks for regions, stabilization scenarios. Even though the primary goal of Working Group 3 is to look at mitigation and other policies, we were asked in the context of impacts and vulnerabilities, how could those vulnerabilities be reduced under at least the umbrella of stabilization? And then finally, the last bullet is uncertainties, and it's inconceivable when anybody is dealing with a system as complex, not just as the climate system, but the coupling, the interaction of climate systems and human systems, that there wouldn't be substantial uncertainties, which is why we have confidence ratings. One more point about uncertainties, having been the co-author of the guidance paper on uncertainties for the previous assessment report, what we asked assessors to do and what has been done since is not just to state that there's uncertainty, but to rank the components of the issues which are well established, and there are many, from the components of the issues with competing explanations, from the components that are speculative. And all too often they get lumped up in the media debate and create a cacophonous picture where people are confused. So the job of these assessment reports, whether IPCC or the National Research Council, is to try to separate those out. The next picture well, I'll just talk to it then, is that, well, okay, if the slide were showing, what it would be showing is that in the process of identifying that, we can come up with a number of items that are, quote, key vulnerabilities. The context was avoiding dangerous climate change, and many governments said, well, could you in Chapter 19 give us some guidance on avoiding dangerous climate? And we said, no, of course we can't, because the choice of dangerous is a value judgment about how you weigh risks of potential climate changes versus the risks of spending money that you want to use for other purposes. That's your job. But what we can do is we can give procedures whereby we can make it clearer what the trade-offs are and what the criteria are for which people in the literature have identified things as key. And we came up with a list of 7 criteria, and I'll end with these: the magnitude of impacts, timing of impacts, persistence and reversibility of impacts, potential for adaptation, distributional aspects, meaning do rich get richer and poor get poorer, or the other way around. Likelihood, uncertainty is very important, and the importance of those systems, and no statement could be more of a value judgment than importance. And we explicitly stated that it is not the role of science to define or explain which vulnerabilities are key, but it is our role to try to help to give criteria whereby stakeholders and decision makers can be more ordered in their capacity to make their own judgments, and that's why the chapter lays that out. This was explicitly stated in the chapter. It is explicitly stated in the testimony, though a little bit of it was removed from the summary for policymakers, but the important gist is still there. Thank you very much.
Thank you, Dr. Snyder. At this point, we will have our questions, and I'll open the questions with recognizing myself, the chairman, for 5 minutes. Excuse me. Could you put back up one of Dr. Snyder's exhibits, please? Any one of them would be fine. Dr. Snyder, I noticed that. Well, let's go back to the first one. Let's go back to the first one, if you don't mind.
The one after that.
Yeah.
That's the one that never came up.
Let's go back to the first one, if I could. The one before, okay. Dr. Snyder, I noticed, I guess in the later, it's after that, I believe, in that, where there are some red and some black statements. How are those distinguished?
Well, I put in red those things to call to the committee's attention in short testimony. The identification of potential key vulnerabilities was designed to provide guidance to decision makers on the levels and rates of climate change that might be associated with dangerous anthropogenic interference, or DAI, which is exactly the terminology of the UN Framework Convention. And I remind those here, some may not remember, back in 1992 at the Rio meeting, that was signed by President Bush at the time and ratified by the U.S. Senate. So this is, in fact, the law of the land, and the second most signed treaty, I believe, in world history. But the most important sentence is the one below that, which is ultimately the definition of DAI, dangerous anthropogenic interference, cannot be based on scientific arguments alone, but involves other judgments informed by the state of scientific knowledge, and that no single metric can adequately describe the diversity of these vulnerabilities nor determine the ranking. We get over 1,000 review comments, and that was, I think, our most praised comment, because we were open and forthright in saying that its judgments have to be made by individual decision makers on their own criteria, and it is not our job to give you the answers.
Thank you, Dr. Snyder. And have we reached the point yet where scientists believe that there are some impacts of climate change that cannot be avoided even with aggressive mitigation?
Yes, I think that in Working Group 1, it's very clear that the 0.75 degrees Celsius, something like 1.34 degrees Fahrenheit warming since the Industrial Revolution, we can't roll that one back, and the probability that we'll be able to hold the line on current emissions is very, very low given world development patterns, and that we're committed to at least another degree or two of warming at best, and at worst, I believe their top number was 6.4 degrees by the 2090s.
And the Pentagon released a study that discussed the possible security risk caused by climate change. What risks do you see associated with climate change?
Well, I think that the risks, as we stated in our chapter, are those people already most vulnerable, which tend to be poorer people living in hot countries, people living in Hurricane Alley, in high mountains where glaciers are melting, in the Arctic, Mediterranean climates like California or the Mediterranean. They are the highest risk of natural climate variability. And if you add on top of that additional components of stress from human activities, they're the first groups to be feeling the effects. The only groups that would feel them even more severely would be natural systems, species, because they don't have the conscious adaptive capacity to put in irrigation systems to deal with their plight. They either can move or they can't. And those kinds of issues, I believe, are the ones that are most serious. And what the Pentagon was stressing is that in areas where human behavior and political situation have already created a stress situation, an additional stress on top of that could be a tipping point. I believe that was the sense in which they were concerned about climate on top of everything else.
Thank you, Dr. Snyder. Let me just conclude with a question for everyone, and I want you to feel no qualms about disagreeing if I'm not stating or summarizing the overall report. And I want to make, I understand that, and I'm going to repeat to you what I got from it. Again, correct me if I'm wrong. I understand that we have observed evidence that global warming driven by human activities is having an actual impact on physical and biological systems. Is that true? A lot of vertical nods.
Yes.
So please,
yes,
okay.
That's
so
true.
just anybody, if you don't agree, please raise your hand because I want to get this on the record. The impacts are mixed, some beneficial and some negative, but without taking steps to adapt climate change and to mitigate greenhouse gas emissions, impacts will tend to be more negative than positive, and this trend will get worse over time. No. Okay. We are going to experience climate change for several decades, no matter what we do. But this assessment suggests that if we take action now to reduce greenhouse gas emissions, we can avoid or at least delay more severe impacts of climate change in the future. Is that true? Still all vertical nods, all right? So we need policies that promote both adaptation and mitigation. We need adaptation strategies to cope with current and near-term climate change impacts. We need mitigation strategies to adapt and to further future impacts so great that adaptation will not be sufficient to cope with the mitigation or rather magnitude of some projected changes. And have I gotten the thrust of this report correct? Thank you very much. And again, thank you for your time. And I yield to Dr. Ehlers for 5 minutes.
With that, Mr. Chairman, we wish we had you as a lead author on our report. It's very succinct and accurate.
Or in Brussels.
Thank you, Mr. Chairman. With that succinct summary, I'm not sure we need to ask any more questions. Let me just, first of all, Dr. Pulwarty.
Yes.
Your emphasis, your comments here was almost entirely on management and adaptation. Does this mean you and the panel have basically given up on the hope of reining in CO2 or methane emissions?
No. The response is geared towards the chapters that we were actually tasked with writing. As was stated in the earlier comments, I think the combination of mitigation and adaptation is necessary. The management components become very important in the near term because of the commitment that we already have in the system with excessive CO2 already in the atmosphere. So for us, it's not necessarily a trade-off, but a two-pronged activity. One of the things that the adaptation focus helps us with is to embed both natural climate variability and climate change as in an integrated response to dealing with climatic risks. So both are still important and still equally important.
Thank you. Dr. Agrawala and Dr. Pulwarty both. You talked about, or the report predicts that drought-affected areas will increase. And I'm curious, what parts of the U.S. are vulnerable to this? I participated in a conference on this last year where I spoke, and one of the authors suggested that if at current trends, in sometime in the next 50 or 75 years, Indiana would look like Texas, which is a horrible fate. I can say that out loud since Mr. Hall has left. What is there any basis for that? Can we expect the great breadbasket of the world, the Midwest, to actually begin suffering from drought?
One of the things we can definitely point to is a trend in drying within the Colorado River Basin, and that's very clear. Reduction in Great Lake levels as well. What I would like to do is ask Dr. Easterling, who focuses heavily on agriculture, if he'd be willing to address your question.
Dr. Easterling?
It's very clear from the accumulating evidence that the western third of the nation dries, and if one looks at a agriculturally meaningful quantity like runoff, the runoff projections under climate change out into the 21st century show a decline throughout most of the significant irrigated agricultural production areas of the country, especially the western Great Plains, where I need not point out we're already seeing declining groundwater levels just through normal irrigation water use, and we would expect that to intensify under climate change.
But when you say the western one-third, you're basically talking the Rockies westward, right?
Well, if one looks at the numbers, and of course they're never totally precise where you draw the boundaries, but it appears to us that the Great Plains, western Great Plains, would be involved in this general drying trend.
They're also facing exhaustion of the Ogallala Reservoir as well. So
correct.
So if we own property in Nebraska or Kansas, we should sell.
Or change to something else.
What about Indiana, the eastern Great Plains?
Well, there may be opportunities to engage in irrigation in the middle or central to eastern parts of the Corn Belt, but I think the studies are yet to have been done to give us compelling evidence that that's a viable option, increased irrigation in those areas.
Thank you. Dr. Burkett, you talked about coastal erosion issues and so forth, and I agree with your concern there. I spent a few days on the eastern coast of the Chesapeake for a retreat recently, and I was just astounded at how only a few feet rise would inundate that entire area. But being from the Great Lakes, I'm concerned about how does all of this impact the Great Lakes in the United States. Someone mentioned earlier they have gone down. It's hard to know whether that's attributable to climate change or not. Do you anticipate any changes in the Great Lakes? Either the rainfall, of course, could affect it, but any other comments?
It was not included in our coastal chapter, and I think perhaps Roger can answer that better than me.
Okay.
Well, one of the major issues regarding the Great Lakes has to do with increasing temperatures as it relates to evaporation. And so the link between a temperature impact on snow that runs off into the Great Lakes and evaporation on the Great Lakes themselves are really where the signal for future lowering of lake levels is coming from.
All right. I thank you very much, Mr. Chairman.
I noticed that Dr. Ehlers didn't ask if any state was going to wind up looking like Michigan.
There can be no equal.
Dr. Baer is recognized.
Thank the Chair. Thank our outstanding witnesses for their testimony. Dr. Easterling, I come from a heavily forested state, and you talked predominantly about, as I followed your testimony, about the impact of growth rates on agriculture. Can you talk a little bit about carbon sinking, particularly in forest products, and the role that forests may or may not play as a sink for carbon? Did the group study that at all?
That was peripherally considered, partly because our chapter was really focusing on wood products and the productivity of the timber industry. But I will say that we would anticipate, based on our studies, in the early stages of the warming, a positive effect on timber productivity in the higher latitudes. That would include, of course, the United States. And as the warming progresses out into the 21st century, that advantage to the higher latitudes grows stronger, and we actually then begin to start to see the tropical latitudes lose advantage, so that from a competitive standpoint, the higher latitudes in the timber industries may relatively be advantaged. Ipso facto, one would expect that as significant carbon sinks, particularly for young managed forests, that we could see great potential for sequestering carbon. Of course, that potential will saturate at some point when we satisfy world demand for timber, and any additional growth would be natural ecosystem growth, and I'm not qualified to comment on that part.
I appreciate that. One of the things we've been looking at in my region is what happens after a fire, and one option is to harvest the trees and sink the carbon in what we call houses. Another option is to leave the trees there to reburn and be eaten by bugs, etc., which will put more carbon into the air. In a rather ironic twist, the, in quotes, environmental community, close quotes, has opposed the harvesting of burned trees, preferring to leave them standing and the perfectly good wood sit there and rot and decay and second burn and produce all that carbon into the air. I kind of think it'd be better to sink it myself and plant some new trees and grow a forest up, but that's a controversy for another day. Dr. Wilson, you look like you might have a comment on this.
I was just going to comment that observed effects of temperature increases already have shown alterations in disturbance regimes such as fire and pests, as you just mentioned. So temperature increases are already having an effect on mid-latitude and high-latitude forests.
We see larger and larger areas of acreage burned virtually every year. It's just a pretty steady increase, and we see bug infestations that some of us would also like to address. And again, I think there are significant carbon issues there. And at some point, I'd be very interested in if any of you have insights into somebody who might be able to give insights into the relative pros and cons of leaving burned timber to stand or to harvest it and sink it. I'd sure appreciate that. Yeah, none of you talk at all about, I know we have a limited-sized panel here, but no one spoke about the impacts of fishing, which for our coastal and Michigan communities as well is pretty important. What are any insights from the IPCC report on impacts of fishing or aquaculture, commercial or recreational?
In terms of fishing impacts on coastal systems, most of the marine fisheries and coastal fisheries are estuarine and wetland dependent. The detritus and the carbon export from the wetlands, particularly in the South Atlantic and Gulf regions, that's what determines fisheries productivity. And so as the wetlands go, as the coast goes, so goes the fisheries in general. So
the premise both on a nutrient and on a habitat and a rearing kind of situation, you might see a decline in there because you've lost the areas for maturation.
Right, and initially you might have a boost in productivity because of the declining material going into the estuary.
So I see. Dr. Pulwarty?
There's also a related impact on in-stream temperatures and decline of salmonids, trout fishing, and so on.
Dr. Schneider.
Yes. Thank you. Some fish might be able to, warm fish might be able to replace cold fish, so it might not be easy for the grandfather to teach the grandchildren to fish precisely the same species. One hopes at least there's some replacement. But the one area where there seems to be greater concern, a little less relevant to the United States, but certainly relevant to the world, is the threat to coral reefs through a combination of increasing temperature, and in fact, that's one of the lowest thresholds, 1 to 2 degrees additional warming in Celsius, leading to extensive bleaching, beyond that extensive death of corals. And those coral areas are a great breeding ground for fish of all kinds, and that's further exacerbated if we really do double and triple carbon dioxide. That makes the oceans more acidic, which would be a threat again to any calcite-shelled creatures, including corals. So that would have a significant impact on fisheries on a planetary scale, given the incredible importance of reefs as breeding sites.
Thank you, Dr. Stein. I witnessed this personally some years ago, and not that long ago, about 5 years ago, in the Maldives Islands, where they had, if I remember correctly, about a 90-degree. It's amazing to think of ocean temperature at 90 degrees for about 3 weeks long, and it basically wiped out 90% of the coral, and it was really tragic to see what had once been a magnificent coral zone, basically looking like gray hulks of dusty debris.
Gentleman's time is
sorry. No. I was just going to say that, in fact, these are all part of a natural variability, El Nino and other such things, so people think, oh, well, it's normal and they'll recover. The problem is when these fluctuations, which can cause bleaching, occur with a decreasing time between them, which is exactly what happens on the rising tide of overall warming, then what you do is you don't give the reef enough time to recover naturally, and that's precisely how global warming would interact with the natural variability and threaten those natural systems.
Gentleman's time expires. I understand that Chairman Bowler took a group to the South Pole in his last term, and they stopped at the Great Barrier Reef on the way, and they saw firsthand there, as reported to me, that it was very visible that reef was dying. Dr. Bartlett is recognized for 5 minutes.
Thank you very much. Thank you for your testimony. The world faces the simultaneous interaction of two multi-decades-long tsunamis. One we've been talking about today, global warming, and the subsequent climate changes. The second is reflected in two articles that appeared recently. Just a few days ago in the Wall Street Journal was a front page article that noted that the world's second largest oil field, Cantarell in Mexico, had declined in production 20% in the last 2 years. About 3 weeks ago, there was an article in the Washington Post, unfortunately not on the first page, where it's important should have placed it, which was talking about corn ethanol production. As you know, we produce relatively insignificant amounts of corn ethanol in terms of replacing gasoline, but it's doubled the price of corn, and tortillas are now more expensive, and Mexicans are hungry, and my dairy farmers are going bankrupt because the price of feed for cows are up. This article noted that if we use all of our corn land for ethanol, we fed no animals and no tortillas for us. And if you discounted that ethanol production for the contribution of fossil fuels, which the authors of the article said was 80%, I generally use 75% to be generous, that it would replace but 2.4% of our gasoline. That's all of our corn made into ethanol. And the authors noted that you could displace as much gasoline if you simply tuned up your car and put adequate air in the tires. These two articles, of course, are referring to the coming critical energy shortage in the world. Peak oil is a phenomenon which more and more people are now focusing on. And of course, the shortage of these more readily available fossil fuels is going to result in increased use of coal, which in terms of CO2 production is really a very bad actor as you convert the coal to liquids and to gases. Did you in any of your deliberations consider the simultaneous interaction of these two forces? Clearly, if you're talking about, and I noticed one of your chapters dealt with adaptation practices, options, constraints, and capacities, did you just assume that we're going to have this, the present availability of energy? Isn't it very probable that the impacts of climate change are going to really be exacerbated by energy shortages and high prices? Yes, sir.
To be sure, the issue of energy in agriculture and food production is huge, and this was a growing concern, the rising prices for energy as we began the IPCC, and it became very clear that as we looked out at the adaptation possibilities for food production, that there would be this growing competition between food and energy, bioenergy. And although our task was not to analyze the energetics of bioenergy, I will say that several of our authors have commented that it is not likely that the energetics of using corn grain for ethanol will ever make sense, and that as a placeholder for the use of cellulosic conversion to bioenergy, that is using some grain, but also using the other parts of the plant, the stover, plus also bringing into production woody products, wood chips. That makes eminent sense going forward. But this is all outside of the central task of the IPCC. It will have to be a topic we consider in the next round.
On the 14th day of next month will be the 50th anniversary of a speech given by Hyman Rickover at St. Paul, Minnesota, to one of you is nodding your heads, you've read the speech. I would encourage you to do a Google search for Rickover and energy, and that will pop up. You will find it a very revealing, very prophetic discussion. He suggested that competition for food and fuel would result in scarcities of food for people. Thank you very much, Mr. Chairman.
Thank you, gentlemen. Time has expired. Ms. Wolseley is recognized for 5 minutes.
Thank you, Mr. Chairman, and thank you to the witnesses. I'd actually like to say that each one of these witnesses could be a hearing in and of, and the topics in and of itself. Thank you. Certainly we heard from all of you that global warming is a huge concern, and I'm hearing also, and I don't think that the chairman asked you to nod your head on this, that it's not only a concern in the United States, it is a concern worldwide. Dr. Baird and I just returned, we spent the first week of the Easter break in China at a U.S.-China relations conference. And we started out in Shanghai, where there's more high-rises than any other city in the entire world, and you can't breathe. I was just struck by the development in China and the atmosphere and the environment. I took my All-American football player son with me. He got a nosebleed. My eyes got all red. We could not drink the water in the 6-star hotels in our rooms. I mean, give me a break. So, in our conference, I asked the question of the Chinese government representatives, the question of global warming, and that discussion got going. And the Chinese government representative's response was, well, the United States has used up, more than their share with 4% of the population and 25% of the use of resources and probably equal amount of pollution, their share. Now it's our turn. Well, of course, that doesn't work. There's no time for that turn. And so, of course, we talked about that. So my question to you is, where do you see the international effort? Where is the United States' responsibility? Because we do have some making up to do. I mean, we've certainly used more than our share. Stress, natural systems, etc. A word you'd never used was greed. And it all comes into play. And if you'd like to respond, I'd certainly like to hear it, of how much more can we do, how much does the international population world, what do we have to do, and how fast do we need to be doing it?
Well, I'll take a shot at it, but this is not directly in the purview of the IPCC, so I'll respond personally, but I've been a veteran of many, many such international meetings, and I can report on what I have seen and how I interpret it for you in this connection. When you go to international meetings, typically the Conference of the Parties, you hear exactly what you said, Congresswoman Woolsey. You see blame. You'll hear developed countries pointing out about corruption, lack of markets, insufficient development, overpopulation, pointing fingers toward the developing world. And then you'll hear from the developing world a legacy of colonialism, market share interference, and an absolute greedy reluctance to give up any measure of your consumption. Of course, they're both right. And the question is, if you're going to deal with a problem which is a commons problem, where it's the collective integration of all of our individual actions, national, state, and federal actions, which create the problem, then we have to have cooperative solutions. And cooperative solutions involve deals. They involve win-wins. And in the case of the international one, my view of that is, yes, we have a right to ask China and India not to hold the sustainability agenda of the planet hostage to their notion of the inequity of their development, but they also have a right to ask us to help them with that process, since we're a factor of 10 per capita more consumptive than they are. So rather than blame, making deals where we get public-private partnerships with international backing to try to help invent our way out of it, not just here, but also there, and then the ones who are cleverest enough in the invention also have partial ownership in the patents, you then start to be able to approach the problem. But it's very difficult to have that kind of cooperation until people trust each other, which is why it's so important to have international cooperation. And countries that created the most of the problem, which unfortunately 80% of the emissions accumulated are from the 20% of the richest countries, we do have to take initial steps that will be stronger and more costly than other countries, or we have no credibility. But your point is completely right. We can solve it together if and only if we can cooperate.
Dr. Rosenzweig.
I'd like to comment on the IPCC scientist part of this. That in the testimony that I read, one of our lead authors was a Chinese woman hydrologist. So the effects that I read about the river changes in the rivers came directly from her. And so I believe that working together as scientists is one way of establishing the cooperation that is needed to go forward on the issue.
Thank you. And the gentlelady's time has expired. And unless there's somebody that feels, yes, Dr. Esterling.
I wanted to respond just in the context of food security. The United States has been the supplier of last resort of food for decades, and it is clear to us, as I showed in the differences between the tropics and the mid-latitudes, that there will have to be some movement of food across large areas through trade. I would not advocate a system of food aid per se, but I think the U.S. will have an obligation to facilitate the relatively unrestricted movement of food and fiber into those regions that need it the most, and to do it in a way in which the local farmers are not so disadvantaged by the trade that the internal capacity, the domestic capacity in African countries, for example, is not greatly diminished.
The gentlelady's time has expired, and I will tell the gentlelady we are looking at a hearing to go more into this specifically in the near future. And Dr. Gingley is recognized.
Mr. Chairman, I thank you. As I sit here and listen to this somewhat doomsday scenario, I turned to my friend on my right from California, and I told him that not all is bad. One of these days, maybe he'll be surfing on the west coast of Georgia. But I thought, Dr. Snyder, your response to Lynn Woolsey's question was the most succinct summary that I've heard in regard to this overall issue of science and policy. And although I don't think you get any naysayers in regard to the science on this committee on either side of the aisle, either the majority or the minority members, clearly at some point, and some point soon, we're going to have to address the science with sound policy. So that's why I'm so appreciative, Dr. Schneider, of your remarks. I want to address my question, though, to Dr. Agrawala, our friend from Paris, by way of Princeton, because you talked about adaptation. I think a lot of your testimony dealt with that. And really, it seems to me that this working group, too, it has spent a lot of time, the testimony, all six of you, in regard to adaptation versus mitigation. And I would like for you to maybe start with Dr. Agrawala in giving us some examples of how adaptation might work versus mitigation and what the relative cost-benefit ratio. I'm thinking, of course, in terms of the early 19th century, early 1900s, I should say, 20th century, when the automobile came along with Henry Ford, and what did people do with the horse and buggies? Well, clearly the federal government did not have to force them out of those horse and buggies. They adapted, and it seems to me that there's great potential for adaptation. There's also need for some mitigation, but striking that balance. So if you would address that for us, Doctor.
Thank you, Congressman. You're absolutely right. There's great potential for adaptation. I think one of the key messages from our chapter, and indeed the entire Working Group 2 report, is that we need both mitigation and adaptation. What we do in mitigation now will have impacts on the climate system only in several decades. So there are a number of near-term impacts of climate change we are already committed to, and there is no option but to adapt to them. At the same time, adapting to unmitigated climate change over the long term would be beyond the possibility of many systems, both natural systems and human systems. So we need a portfolio of responses which encompass both mitigation and adaptation. You're also right in saying that a lot of adaptation would happen autonomously. When people are faced with changes and different risks, they take a number of decisions. And our chapter actually documents a number of examples where a number of actors have taken observed changes in climate change as well as scenarios for future changes into account. There are examples, for example, of infrastructure projects. The Copenhagen Metro, for example, was built higher to take future sea level rise into account. But at this time, these examples remain boutique examples. You can literally document all the examples where future changes are taken into account in a couple of pages. And what we need to do is scale up these examples and have many more of them. The problem we run into is that even though there is wide familiarity with the seriousness of climate change and the impacts, we still don't have specific information for particular users to take those concerns into account when they make decisions. And the questions from users are often, what is going to happen to my farm plot or my watershed or my city? And we need information at that level of detail. And that's one of the key issues, I think, where government policy and scientific research can play an important role. Just a quick word about the costs. The costs of mitigation were not covered by the Working Group 2 report. The Working Group 3 report would be discussing this in a month's time. We did try to look at what we know about the costs of adaptation, and our knowledge remains very limited. I gave you a range, which is nothing more than a back-of-envelope calculation by the World Bank, saying that the total cost of adaptation globally could be between $10 and $40 billion per year. I wouldn't take those numbers to heart, but it does show that there might be significant costs associated with it. We need a lot more research on this particular issue. Some of the research that's been done on costs has been on infrastructure adaptation. What would it cost to build a seawall, for example? And that can be answered. But what's not been addressed is what are the costs of policies? What are the costs of implementation? And if you take certain adaptation measures, what might be the spillover effects on other actors? And I think clearly a lot of work is needed before we can come to grips with this question.
The gentleman's time has expired.
Thank you, Mr. Chairman.
If you have something else, you need to go forward, but otherwise.
No, Mr. Chairman, I'm fine. I know one of the panelists wanted to also weigh in, but I'm fine regarding my own question.
Go right ahead.
I think it's important to realize that and consider that adaptation and mitigation is not always they're not always opposite. They're not always on opposite sides of the fence. There are actions that can do both. I'll give two examples. In cities, having green roofs, vegetated roofs on cities, cool the people below in the buildings. That's an adaptation. At the same time, they reduce their air conditioning costs in the summer. That's a mitigation. So there can be synergies. One more from agriculture. Carbon sequestration in farmers' fields. Mitigation in terms of sequestering the carbon, reducing atmospheric concentrations of carbon dioxide, but at the same time, when we have higher organic matter in our farmers' fields, those farmers can then withstand both droughts and floods better. So while, of course, there's key issues to consider as we consider them separately, but I think it's also important to realize that sometimes, and this is in the chapter, I believe, there was a chapter actually on adaptation and mitigation in work. There are times when they can be synergistic.
Thank you. Dr. McNerney.
Thank you, Mr. Chairman. I'd like to thank the panel for taking time to come up here and for your excellent and informative testimony. I have some detailed questions. Dr. Easterling, what are the sort of adaptations that you envision to prevent crop loss from occurring with rising temperatures? You mentioned that, and I wasn't sure what you were referring to exactly there.
Well, one of the certainties we think of warming is that farmers will have the opportunity in anywhere they grow their crops in this country to alter the planting dates to take advantage of an earlier spring warm-up. They can at the same time alter the types of crop varieties that they plant, because not all crops are the same in terms of how long it takes for them to reach maturity. And there are some maturity classes that are able to handle the longer growing seasons that are likely to occur. In fact, we're already, as Dr. Rosenzweig in her chapter, starting to see increasing lengths of growing seasons, that these would be natural, easy to apply adaptations that no one would have to tell farmers how to do it.
Yeah, thank you. That doesn't sound that bad then. There's a question for Dr. Pulwarty. I'm from Northern California, and much of the Delta is in my district. You referred to the inability of the Delta to provide the water that's required by about the year 2020. What specific mechanisms are involved in that in your mind? And you mentioned a partnership with water planners would help in adaptation. Could you give us some details?
Certainly, from the basis of the last set of discussions that we've been hearing, there's investigated efficiency criteria in terms of how we use water that can actually be introduced. In many areas, we've got more efficient technology for using water, for irrigation, that does not reduce the quality of life in implementation. From the standpoint of the Sacramento-San Joaquin Basin, one of the major signals that we're seeing there is increased early runoff of snow and a declining snowpack. That trend, given current rates of extraction of water and that trend in temperature, the estimates are that by 2020, the system and the Colorado River Basin as well would not be able to meet its demands. So from the standpoint of adaptations and response, there are water banking mechanisms, water tradability, and water rights for purchasing. The key question that is there is a lesson out of the drought of 1987 to 92, in which a water bank was set up. It was a very successful water bank, but the place that the excess water for the bank came for was from the environment. We have to ask whether or not the adaptation mechanisms that we have are in fact viable under the conditions of climate change and variability. So we've learned to do some things better, there's no question about that, and water banking is one of them. I do want to mention relative to that, in terms of efficient water technology, there's a huge emerging market in developing adaptation technology in which we could be engaged.
Thank you. I yield back. Thank you. I'll now ask our panel to buckle up and recognize Mr. Robacher for 5 minutes.
Thank you very much, Mr. Chairman. Let me just note that it is really important that we have such discussions as today. However, let me lament that much of the discussion about global warming has been controlled and skewed in favor of alarmist predictions. We've been, for example, treated to the predictions of gloom and doom that are based essentially on extending trend lines so far out that it becomes totally indefensibly scientifically, that you would say, well, this trend over the number of years will mean that in another 150 years that this is what it's going to be. I'd like to submit for the record a article by Richard Lindzen, who is a distinguished professor of MIT. Unfortunately, this Newsweek article, I wouldn't even know about it if I was an American citizen, because it made it into the international edition of Newsweek, but didn't seem to make it into the national edition of Newsweek. In this article, he says there is no compelling evidence that the warming trend we've seen will amount to anything close to the catastrophe being predicted. The Earth is always warming or cooling as much as a few tenths of a degree in a year, and periods of contrast to the average temperatures are rare. Current alarm rests on the false assumption that not only we live in the perfect world of temperatures, but also that our warming forecasts for the year 2040 are somehow more realistic than the weatherman's forecast for next week. And let me note that this is a distinguished professor from MIT. There are many such professors who are totally dismissed, and as I say, this didn't make it into the American edition. In that same edition, I just happened to be flying back from Europe yesterday, and I read this. In the same edition, there is a article about a study, Mr. Chairman, a very well-financed study that indicates that we should be chopping down all of the trees in the world in order to combat global warming. The effect of chopping every tree would actually, and this is a scientific study, that would then give us actually a cooler situation than if we left all the trees up. Now, again, I'll submit that for the record when I find it. I just had to look this up on the Internet. There are also many quotes that I will put into the record at this point of highly respected scientists. And on this, in terms of today's hearing, we have a quote from Heinrich, and I don't know how to pronounce his last name, Tenekes. Yes, a former director of research for the Royal Dutch Meteorological Institute and professor of aeronautical engineering at Penn State, in which he states, "I protest the overwhelming pressure to adhere to the climate change dogma promoted by the adherents of the IPCC." So let's get a little of this on the record, part of the discussion. I think it's really important for us to have an honesty and a broad-ranging discussion rather than a controlled discussion of this issue. The last time we had a hearing, and I in jest mentioned that
Perhaps dinosaur flagellants must have caused the first cycle of global warming. Totally unjust, actually making fun of the position that people say we can control animal flagellants today, and that's the way we're going to prevent global warming. In fact, it was widely reported in the press that I was serious about that, which indicates the people reporting it, controlling the public discussion, are either dishonest or incompetent. So with that, let me ask a couple questions of this panel. It was really cold when I landed here. It was cold, and I was wondering, in recent years, has it been getting warmer or colder? Last 5, 6 years? What's the temperature? Shall I pull out somebody else to tell you that the studies are indicating that it's actually getting cooler in the last 6 or 7 years?
I think the panel can answer that, probably by repeating what 113 countries, including the United States, said at the last IPCC report. Would any member of the panel like to do that?
Is it getting warmer or cooler in the last 5 years?
Fair question.
It's at the global scale, it's harder to see a trend in 5 years. If you're
I didn't ask about the trend. I said, is it getting warmer?
No climate scientist would discuss climate in a time frame much less than many decades, so therefore we wouldn't look at what happens in 5 years. We'd look at over a period of 30 where the trend is very clear. But it's irrelevant to climate.
Sir, I take it from your answer it's getting cooler, because every time you ask a pointed question that seems to go in the other direction, we get this, juggling act of trying not to answer the question. Let me note that even on the chart that I've been presented by the so-called experts, we see that the global warming of 1.5 degrees has taken place over 150 years, starting in 1850. Let us also note that 1850 reflects something else. It reflects the bottom end of a 300-year decline in the Earth's temperatures by these very same people who have tried to reach out and to find out what the temperature was in the past and what it is going to be in the future. You don't start off a trend line at the very bottom of a decline and say that this is the average that we're going to face into the hundreds of years in the future. There are a lot of things like this that tend to lead me to not to suggest that there isn't some warming going on, because there obviously is warming going on. The question is whether it is man-made is another question. Now that we know that NASA has given us reports of the warming that's taking place on Mars and other planets, that would suggest to me that if there is some warming, it may be due to sunspots more than it does to human activity. And if human activity ends up trying to control our lives, it will be in a way that prevents industrialization, etc. We are going to pay a severe price for this type of alarmism. One last question, if I could get it out here, is about these predictions, and I guess I should just leave it at that.
Well, the gentleman's time more than went over, but I thought that it was important to let the minority of the minority get his point on the record. So a lot of minorities turned out to be right in the end, right? It makes us all think. So we thank you for that. And the gentleman from Louisiana, Mr. Melanson, is recognized for 5 minutes.
Thank you, Mr. Chairman. I appreciate it. I guess one of the things that I feel needs to keep being pointed out, it's not just global warming, but it's climate change that's occurring, and it's a combination of those factors. And I don't think we're talking extremism. I think we're talking about adaptation and mitigation and the art of making deals to get this thing moving in the right direction. I've got a grandson, so I've got a new vested interest. I've got children, too, and don't know if I'll ever see my great-grandchildren. But I grew up in the South Louisiana marshes, which Ms. Van Sickle is extremely aware of and cognizant of the importance it is to this entire nation and not just Louisiana. I hope that whatever we do in the Congress will leave that estuary, that great area of this country, which most people aren't aware of, whole and back to where it should be so that America can benefit from it. So I'm going to concentrate, I guess, on the coastal areas, the restoration, the rising the rising sea levels and such. And Virginia, Miss Burkett, Dr. Burkett, one of your key policy relevant findings states that the coastal wetlands ecosystems, such as salt marshes, are especially threatened where they're sediment starved or constrained. Would this assessment apply to coastal Louisiana?
Yes, coastal Louisiana is one of those large mega deltas that is extremely vulnerable. Do you know that all these deltas around the world now, whether you're off the coast of Vietnam or the Nile Delta or in Shanghai, these deltas were formed during the past 7,000 years when sea level rise was relatively minuscule, very small. They're all very vulnerable to even slight increases in the rate of sea level rise, which are very likely to increase during this coming century. So the Louisiana coast is just quite vulnerable. That's why it's listed as a hot spot of vulnerability. That said, though, a lot of the coast can keep pace with sea level rise even if it doubles, if you can get the fresh water and the sediment to that marsh so that it can accrete vertically in place. So it's not a hopeless situation.
And I guess that brings me exactly where I hoped you would go with it. The influence of human development and activities along the coast and adjacent watersheds, and the Army Corps of Engineers through the years since 1927, when we decided we needed to harness or keep within the levees, the Mississippi River. While facilitating navigation, we've contributed to the living conditions by accelerating soil compaction along the coast. So what has man, and I refer to it when people ask me, why doesn't the Congress understand what's going on down here? I tell them that, the Corps is partly at fault, but so is the Congress of the United States, because all these years we've been funding wants, and the concerns of the Mississippi River with the locks and dams and the other structures has that man-made situation along the Mississippi River, which does everything from the Alleghenies and the Appalachians all the way to the Rockies and everything in between. Louisiana is the final resting spot for everything, for the good, for the bad, and has that harnessing of that river and channeling of that river caused the severe problems that we're experiencing in coastal Louisiana.
It's the most significant cause of wetland loss in Louisiana. There are over 300 dams and reservoirs along the Mississippi River drainage that prevent the sediment and fresh water from getting into the river, and then it's been levied all the way from Cairo, Illinois, down to Venice, Louisiana. And so the seasonal overbank flooding that would be required to sustain those wetlands, especially in the light of accelerated sea level rise, the ability of that river to maintain that delta. We have a riverless delta, basically, because of what the human influence along the river.
Yeah, and then there's some people that don't believe that there's an hypoxia zone down there. And had we been through the years taking the material that we're just summarily putting into the current and let run off the outer continental shelf, forming this hypoxia zone, which is, of course, the nutrients and whatever that's coming from the farmlands all through the Midwest and northern United States, would it help us at all if we were able to capture that sediment and, with the help of our government, get that sediment back out into the marshes? And does that material, in effect, become a nutrient for the marshes, whereas they're hypoxia in the Gulf?
It would. You've got 120 million tons of sediment just slipping past New Orleans every year out off the edge of the continental shelf due to flood control works, basically, not to the benefit of Louisiana as much as up the river. So, getting that sediment out into the marsh would counteract these changes that we're talking about, the accelerated sea level rise and the increase in storm intensity that will have a dramatic effect on low-lying coastal wetlands like Louisiana's.
Yeah, the one of the things that, of course, I guess I experienced some frustration here is that the relevance of the marshes to protect the cities of our that are inland cities, for instance, New Orleans. And there's some people appear to think that New Orleans is expendable. But I go back to when the French took New Orleans and why it was taken and then why America wanted it. It was because it controlled this country's midsection and all the commerce, and to this day it still does. And the importance of that city, while may not be expressed in national revenue, which I think we could document it does, Without these coastal wetlands, out there is the buffer. We are the first that get the problems from the rising elevation of sea level. But I think, is it fair to say that in generations to come, all America, particularly the south central part, or the south and center part of the American states, need to be aware that it won't take be long in terms of my lifetime, but before we start seeing a real problem for the center part of this country, along the Gulf Coast in particular.
Not just because of transportation down the river, but also because of the energy development off the coast there. As you know, we've got about 3,600 oil and gas platforms off the Louisiana coast. All that product comes on shore. The Loop offshore terminal, you know, that product comes on shore. Two-thirds of this country's imported oil comes through those coastal facilities, and they were all built in shallow waters, in a low-energy environment protected by barrier islands. But the barrier islands, as I showed, you know, they're decreasing, and so it's going to have an impact not just in Louisiana. Will affect our country, have an international impact.
The gentleman's time has expired.
Thank you, sir.
I think, you know, my grandfather used to say the most important road in the county is the one in front of your house. And I think what we're starting to see is that this discussion is moving from the hypothetical to the specific, which it's unfortunate for the country, but it is probably better for the continuing discussion. The gentleman from California, Mr. Bilbrey, is recognized, and then Mr. English will be recognized.
Thank you, Mr. Chairman. I'm sure the gentleman from Louisiana, short of basically eliminating the levees on the West Bank, you know, we're just going to have to address the fact that Algiers is protected from floods, and places like Homa and Bayou Terrebonne have been protected for 100 years, and that protection actually has created a lot of the problem. And I wouldn't want to have to be the representative in that area, having to address that issue until, and I've been down there at town hall meetings in Billy Tozan's old district and try to tell them that, yeah, we're going to be removing the West Bank levees because we need to use that to replenish your shoreline. But that may be, a lot of those areas are been protected from inundation, and that inundation is what's over the centuries actually built it up. And you're in a real catch-22, and I appreciate that. My wife's from New Orleans, so I spent a lot of time. My father's from that part of the world. Mr. Chairman, let me ask the committee, the panel. I come from a background Air Resources Board from California. I did the air plan for Mexico City. And one of the things that I really run into is how do we do the air indexing in third world countries? When you talk about the percentage of first world country emissions and then third world, you know, so often in my 18 years of working on clean air staff, it was like, if it's not reported, it doesn't exist. How do we do an index for a third world country? How do you determine the emissions from countries that do not have true air indexing systems? Anybody know?
In terms of local air pollution, I can't answer that question. In terms of trying to estimate the global emissions of greenhouse gases, there certainly are many international institutions which try to collect that data, and there's always a debate at the margin as to whether the official data represents the actual data. There's been that argument in China about unreported coal burning, for example. But most of the colleagues I have, I don't myself do this work, but I've heard many talks on it. Most of them who do it believe that they think they're accurate to 20% over time.
Satellite photos using for how much slash and burn is going on, and an estimate of how many tons are being emitted per acre or hectare?
There are a variety of techniques that people use, including talking to people locally. But you're correct that the data is not perfect. It's certainly accurate, I would guess, at the planetary scale to tens of percent.
Let me just tell you,
I would suggest that's one reason that we're trying to get IMPOs up, and with those sensors can be helpful in this regard. And it's important that we clean that program up and get it working if we want to get that good information.
the gross deficiency in the estimate of emissions have all been a bigger problem than anybody's willing to admit for a long time. The evaporative emissions in California, which has the best area index in the world, kind of came up, underestimated by 85%. And let me just sort of congratulate whoever's brave enough to stand up and say corn ethanol is the equivalent of an environmental Jimmy Swaggart. The fact of claiming that you're helping the environment by doing what we're doing with corn ethanol, I just think that we just got to start saying the emperor has no clothes on this issue. And in California, we've run into this problem of you don't dare say anything against corn ethanol. But getting back to, is anybody here able to comment on an issue that is going to be essential for us? Because this panel is going to have to develop strategies and techniques of how to address this issue. And if we do not have the proper information going into the process, what comes out is not going to solve the problem. May actually make the problem worse. And I just like to say, has anybody here got a handle on this global dimming issue? Because you've got to understand that may totally change our implementation strategy if it's enough of an issue to justify a scientific review and a policy change. Anybody got a comment on global dimming right now?
Okay, I'll try that again. Since the beginning of my career, I was weighing the global dimming associated with hazes around the atmosphere against the warming from greenhouse gases, and we made the initial assumption that the hazes, the dimming, was global. And in fact, if the dimming were global, it would be a larger cooling effect than the greenhouse gases. What we discovered shortly thereafter, and I was proud to publish before I got attacked, was that only about a sixth of the world was really experiencing very large increases in these hazes, the industrial areas and the biomass burning. I think that the problem you have is that the direct effects of the dimming, that means in between the clouds when radiation comes in and it's reflected back out to space and causes a slight cooling, is well understood. What's not well understood, and this is very clear in IPCC Working Group 1, is that dust particles are the centers upon which droplets in clouds condense, and clouds are the primary reflectors of solar energy. So this is what we call the indirect effect. And the indirect effect could be quite significant, and in fact, one of the reasons you see IPCC tell you 1 degree to 6 degrees C, which is an incredibly large range of uncertainty in warming to 2090, about half of that is due to the uncertainty in how the clouds and the reflectivity will change. So that's real. What we don't know is exactly in which direction, because soot particles are dark and could cause the climate to warm. If they get into clouds and cause them to evaporate, they would enhance warming. If they actually increase the number of drops, they can enhance cooling. And that's why you will find that most honest scientific assessments, and most are, talk in ranges and bell curves because of the issues you raised still remaining not entirely resolved.
The gentleman's time expires. Ms. Gifford is recognized to learn more about the report's impact on Arizona.
Thank you, Mr. Chairman. Let's assume that we keep doing business as usual. I do represent Southern Arizona. I'm very proud of that area of the country. But just 2 weeks ago, right before the recess, I was able to co-host Dr. John Overpeck from the University of Arizona, who's a climatologist and one of the authors of the first IPCC report. So I'm curious if this panel will address, if we continue to do business as usual, we don't take any steps, what is going to happen to the west, particularly Southern Arizona, in terms of water resources, in terms of our forests, also possible changes in terms of immigration with a border country like Mexico, invasive species, wildlife, and human health.
I'll take that. One of the major things that we're seeing in terms of the projections, as I mentioned, is in terms of decline of water resources within the Colorado Basin itself. And as you know very well, 8.23 million acre feet come from the upper basin into the lower basin. A big aspect of that, especially as it relates to Southern Arizona, of course, is the Central Arizona Project, and it's right in terms of the Colorado River. What we're projecting is that by around 2020, demand will in fact exceed supply, given current trends in terms of drought and given current trends in terms of temperature and its impact on snow. One of the things that we should keep in mind, regardless of how change is attributed, human, natural, or both, is that we have to adapt. There will be floods, droughts, and hurricanes in the future. There's no denying that. I can't say very much about the migration issue. It's not an area that I know anything about. From the standpoint of southern Arizona, what we're seeing is increased pressure on groundwater resources for development purposes, and increasing reduction in reliability of Colorado River flow to support that. There's a slew of other issues that's related to that we're beginning to see as a result of dryness. Some of them include dust storms, as you saw last year. There's a storm blowing into Phoenix. There's quite dramatic pictures of it. And dust is known to have a negative effect on snow and snowmelt as well. So there are combined issues from the standpoint of water resource reliability for southern Arizona.
One general principle that I think we all operate with when asking the question, how might climate change affect any of these systems, is that in environments that are already very dry, like Arizona, that most of the natural ecosystems are in very delicate balance with the climate conditions, and therefore relatively small changes in climate can result in relatively large changes in such things as species composition. In other words, the mix of vegetation types, trees especially in your case, that exist in the less managed environments of the state, and that would be of great concern.
The IPCC has undertaken a special report, a technical report on water, a paper on water that Dr. Pulwarty and I will be co-authoring. It'll come out in about 9 months. And if you'd like, we can come and present those findings to you. Some of the implications for runoff in the arid Southwest, for example, suggest through the models, and all this will be captured in the report, a decline in surface water availability and runoff that will intensify during the next 50 years. But we can present.
I would want to add something to what Bill is saying, Dr. Easterling. We have very little understanding of the increased impact on non-managed systems, and you can see it in terms of the pinyon die-off in southern Arizona and changes in the saguaro forest. What I would like to mention in that context is that the present drought that we're experiencing in the basin is 1.5 degrees Fahrenheit warmer than the drought in the 50s. And that temperature stress has in fact created much larger impacts on the non-managed areas than even during the 1950s. So my point being is, however we attribute change, change is happening, and therefore we need to look at adaptation responses.
Mr. Chairman, just a quick follow-up. Some of my concern is Arizona is now the fastest growing state in the nation. So everyone wants to move there. It's a wonderful place, particularly this time of year. But I believe because of this increased growth that we have additional concerns in terms of, we're going to have a lot more emissions. We're going to have a lot more fuel demands. Meanwhile, we have this really delicate ecosystem there, and the situation with the Colorado River water, which I'm afraid that we just don't adequately know how to manage all of this.
One of the things that we have to be clear on is this, being able to picture the risks that we're facing in one setting. There are these increasing population and demographic pressures, as you're describing, but in addition, at the same time, we're seeing more collaborative agreements between Nevada and Arizona on water storage and so on. So we need to look at where some of those adaptation mechanisms are.
The gentlelady's time has expired. Mr. Inglis.
Thank you, Mr. Chairman. Before I ask about seawalls, I wonder if somebody can give me an explanation of the sun theory that Mr. Rohrbacher mentioned and the reaction to that.
I think that's that sunspots are really what's causing this, and it's not really global warming. If anybody would like to address that.
Well, I can address aspects of it. I've worked on the problem earlier, though not recently, and I could give you the names of people who work on it directly now. But again, I'll present the summary from what I've heard from the debates among colleagues, is if the energy output of the sun itself, in terms of the total number of watts of energy over every square meter, had changed significantly, and that were responsible for the warming, then there would be particular fingerprints of that you would see in the system. If you increase the energy output of the sun, you would find the stratosphere, the layer above 10 to 50 miles warming. You'd find the middle of the atmosphere warming, the lower and the surface. If that warming were due to human effects, greenhouse gases, and ozone-depleting substances, then the fingerprint would be a cooling of the stratosphere because of the decrease in ozone plus some other, what we call radiative forcing factors, and a warming of the lower atmosphere. When climatologists in the Working Group 1, again, and you should talk with them about this more, but when they assign high confidence to the fact that humans have been implicated at least in the warming of the last 30 years, it's because that particular fingerprint, cooling in the stratosphere and warming in the lower atmosphere, is what occurred. So it's much more consistent with the notion that it was human effects more than natural. Now, nobody has denied that natural isn't part of it, and in fact, work I have been personally part of using plants and animals as surrogate thermometers, Terry Rood et al., and she's testifying in another hearing at the moment. What we have found is that when we use models driven only by natural forces, which include volcanoes and solar effects, that you predict a small fraction of the observed changes in species, that is, when birds come back from migration, when plants bloom, and so forth. When we use anthropogenic, you get a better fraction, and when you use combined, you get the best fraction. So what we would argue is that the climate of the most recent half-decade is a mixture of human and anthropogenic factors. There's one more component of the sun which is more controversial, which is assuming it is not the energy output of the sun that's created the problems, because this is way too small for that, but that changes in magnetic fields and particles has affected the chemistry of the stratosphere, and it becomes a trigger to create a major amplifier for global warming. It's a very complex, and I would argue somewhat speculative theory. Working Group 1 scientists have considered it unlikely. There's a very passionate debate in the literature on it, and if you ask me formally, I'll be delighted to send you the somewhat unpleasant articles written by the various people who are involved. But the one thing I can say is that those scientists who have claimed that it isn't the energy output of the sun, but it's these magnetic and particle effects, have never shown how many watts of energy around the planet can be affected by their hypothesis, because without showing the scale at which the sun could do it, it's very difficult to compete that against the human effects, because we have very good idea what the scale of human effects are from greenhouse gases, though, as I said earlier, we have much less of an idea about the scale of effects on aerosols. So I think that the jury is still out on the relative importance of the sun, but it's very difficult to dismiss the preponderance of evidence which shows the observational record with and without global warming in the models checked against the observational record. It's very difficult to dismiss that as an accident and require the sun. And my own personal view, having been doing climate theory work now for 35 years, is the sun can't be thrown out as irrelevant, but that in the last 30 years it's probably not a very large component of the major change.
Helpful. Mr. Chairman, I hope I have time to ask about seawalls. It strikes me that, obviously we have huge challenges in places like Indonesia, but we also have places like Hilton Head, South Carolina, which is near where I grew up, some high-value real estate that could be very affected by not many feet or inches, really, worth of change. And just particularly with the discussion earlier of the levees, I wonder how realistic it is to combat that or to see an adaptation involving seawalls. Maybe you discussed this earlier, and I wasn't here, but another hearing. But tell me about seawalls and them as an adaptive strategy.
Seawalls have the effect of preventing the inland migration of coastal habitats as sea level rises. And we point that out in our chapter. Seawalls also and fortified coast tend to prevent freshwater runoff from getting to the coast and sediments from getting to the coast, disrupting sediment transport, back and forth across the coastal zone. But that said, where society deems that protection is the right way to go because of infrastructure or people, whatever, that is important to protect, our reports suggest that the design of those protective structures would be more effective in the long run, more cost effective, if they consider the fact that sea level rise will accelerate this century very likely, even if emissions were cut off because of the changes already made to the atmosphere. And second, that the increased intensity of storms in your area, for example, would warrant a specific design consideration of these changes that we describe.
The gentleman's time has expired, unless, I know this is, again, a local issue. Would you like to explore that any more?
Thank you, Mr. Chairman.
Let me, would the gentleman from Georgia like to conclude?
Mr. Chairman, if you will indulge me, I appreciate that very much, and I wanted to ask really all the panelists, and maybe very briefly to respond. I know, Dr. Snyder, you have, I think I understand, been involved in all 4 of the IPCC assessments, and I would just like to know, in regard to the process, the changes maybe that have occurred over the period of time, this being the 4th assessment, is the product that you're producing now, is there a consensus agreement that it is going to be very helpful to us in regard to the policies that we have to set, and certainly we're going to face that sooner rather than later?
I also have worked on all 4 assessments. The process, and this one as a coordinating lead author, I began 4 years ago with an expert workshop, an expert meeting with experts around the world to begin to do the assessment of the observed changes now, because this was the first time we had a chapter for Working Group 2 on the changes that are occurring now. The process is measured and fully reviewed, and that is the basis of the science. And it's, I think, that strong foundation of the science that goes through expert and government review provides, and for a product that does then stand and provide the document, is the document of record for the following 5 years.
Thank you, Dr. Rosenzweig. Dr. Easterling.
Yeah, I would have to add to what Dr. Rosenzweig has said, and to say that since I've also been involved in more than one IPCC assessment, that it's very clear that the governments of the world are taking more and more ownership of this process, and in a positive way. They're providing the scientists with the key questions that they would like to have addressed, and I think we as scientists have felt that we've been given good guidance and the latitude to be able to, no pun intended, to be able to respond and put our best scientific judgments out for all to see in a very fair way.
Any other? Dr. Pulwarty?
The scale at which the information is produced for the IPCC meets certain needs, that of the international community. What we're seeing, certainly from the climate change science program synthesis and assessment reports, is what that means for different parts of the U.S. and how we interpret and interact with people and the types of decisions that they'll make. So one caveat that I would make relative to the other comments is the process has worked very well, but there's that extra step that needs to be taken, and we're seeing those within the synthesis and assessment reports that are being produced specifically for the U.S.
Thank you. Dr. Snyder.
Yes, thank you. I would share the views of my colleagues that the process is essential for a variety of reasons. And I recall having been involved in many U.S. National Research Council studies well before IPCC. And when IPCC was first proposed in '88, I was asked my opinion about what I thought, and I said, oh my gosh, we spend so much of our time flying around the world, don't do this to us again. We won't reach different conclusions than we've had in the studies in Australia and the UK and so forth. And in fact, its first general chairman, Bert Boleen, said, but the rest of the world hasn't participated, and they don't entirely trust the developed countries to give them the straight story. So IPCC was set up to create credibility across the international community by having the active participation of over 100 governments. They also dictate the outline. So when you asked us, would this be of useful utility to policymakers, the answer is to the extent that the policymakers created the outline which dictate what we must work on, we hope so. But I agree also with Roger Pulwarty that it won't be quite as regionally specific as some countries need, and that's where their own research councils can add a supplement. And finally, that government ownership is absolutely critical for the eventual cooperative strategies that we will have to have, though, as the two staff sitting next to you know, sometimes you have 40-hour sessions to get there, and we wish the process occasionally were a little less contentious, but it is amazingly comprehensive, and the peer review, as Cynthia Rosenzweig pointed out, is why the reports have such high credibility.
Thank you very much, Mr. Chairman. Thank you for your indulgence. Thank you. Since the gentleman brought that question up, let me ask, does anyone on the panel feel like in some cases the summary did not reflect the full views of the information before because of some, for lack of a better term, political pressure? So no one thinks that occurred? Oh, yes.
I've never been one to let the perfect crowd out the good, or to say that an 85% excellent report should be given a bad grade because it wasn't 98. And it's absolutely amazing how much of the basic underlying science was in the summary for policymakers. But there were a few casualties that I think were significant. We had a regional table that would actually have come closer to Mr. Gingri's wish, being more specific on regional effects. Whether it disappeared because in the UN process where consensus, meaning any one or two countries effectively forces a lowest common denominator, was responsible, whether we ran out of time, it's hard to say. I think the single biggest loss from the report was a table that was produced which showed for sectors the relative increasing damage as a function of temperature. It's reflected in the table 19.1 in my testimony, but this was a summary table. Above it in the submission from lead authors was a set of timelines which showed when in 2020s, 2050, 2080s one might achieve 2 degrees, 4 or 6 degrees. Because when you look at the damages and you see them increasing rapidly as you add degrees of warming, but you have no idea whether we're going to be at 1 or at 3 or at 5, what it shows you is a substantial likelihood that we're going to see at least the middle of that range and could very well at first decimal point odds reach the right-hand edge. And we were very disappointed that that was removed on the basis of a few countries' opposition, though we were proud of the United States for supporting that, though we were not thrilled when the United States removed all reference to dangerous anthropogenic interference. I do not know why. But again, anybody who throws 85% of their passes ends up in the Hall of Fame. So overall, we're quite satisfied with the report.
This is a recommendation for B students. Yes, ma'am.
I think very important for the scientists is that the underlying documents were not changed. And so that anyone who wants to see the entire work of the scientists, it is there in terms of the tables and the scenarios, trajectories that Dr. Snyder just mentioned, the confidence levels of every statement are in the underlying document, and that they are not changed is extremely important for the science.
Thank you. Well, all good things have to come to an end. We thank you not only for your testimony today, but more importantly for the years of hard work you've put in. We look forward for 4 years from now hearing from you again, hopefully with better a better prognostication. Under the rules of the committee, the record will be held open for 2 weeks for members to submit additional statements and have any additional questions they might have for the witnesses. If there are no objections, the witnesses are dismissed and the hearing is adjourned.
Thank you very much.
Thank you.